Hi guys, welcome to another video of my YouTube channel. So in this video we are going to see the parametric brick facade, and let's go into the video. So before we create it, we just need either what we can do is we can create a curve and we can make the brick facade follow the curve, or we create like parametric surface and let make it follow that surface. So let's okay, let's create a line for now. Let's say I'll just go with the basic option. Sorry. So I'm going to construct 2 points and the line is 6 and this is like a very basic way to do this, that is create a line. I usually do it like this manual tab, but it's fine. So okay, we got the line. Now let's divide the curve to make a fluid. Now let's create a random value. Random, or you can jitter it. So I will just go with random for now. Jitter is nothing but it shuffles like a random value. Okay. Now I'm going to move this point. So basically I'm just creating a profile for like a parametric surface. So what I'm going to create is I'm going to create two lines and I'm going to loft it. So one will be like this, another one will be like some random. So it creates some parametrical non-planar surface, something like that. So obviously it's like now we don't need amplitude because now we know the direction is like standard. I'm going to use it to 23 and let's see. Okay, now let's keep a range of 200 to 400. I don't know whether it's too much, but let's me try. Okay, not bad, but I want it to be 800. Okay, now let's create an interpolate curve. Interpolate curve, not bad. Okay, and now you can just jitter the value, like you can change however you want. It just gives like multiple options, like it changes the value. Sorry, not jitter, like I said, you can change the seed of the value, like randomizer, like kind of that. And now what we are going to do is I'm going to loft it to see how it looks with this curve, and let's say I want to move it up a unit z, so to a height, what do you think? Maybe like 5000, and let it be the height of this. Okay, 5000 is too much, man. Let's I'll just reduce it to 3000. Okay, yeah. Why it is not working? Loft cannot be constructed. First, okay, let me try to rebuild this. Yeah. So it's okay. I think rebuild was not the problem. I think the flatten was the problem. I think both were in different branch. Yeah. So you don't need rebuild. So technically you see here what I did is, like, if you see here, it's like the first number is 0 and second one is 0 0. It's like 0 0 1. So it's not matching. So I'll often need a list of curves, and this is not a list. It's like a single curve in each branch, which is not a list. So that's why I just flatten it. Now you see something like this. Not bad, but let me reduce this to to minus 400 so that it will be in center. and I can, yeah. Okay, what do you think? For me, like, looks fine. And if you don't want to give it like in a panel, and if you want to give it like a, how do you say, like a number, you can do this like construct domain, where it is, where it, you give like 400 here, start this minus, so go into expression, you can put minus x, or else you can use negative and connect the like that. It's up to your choice. Okay, like so now it's much more easier. You can change it. Ta 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 ta. Now you can like okay. This one not bad. I like what it is, but if you want, you can change it. Now we just need to evaluate surface, and let's say like reparameterize, give range. Let's see what it comes. Sorry. And set point, and it should be z, and it's x-axis. So okay. So I can use cross reference. Yeah. So cross reference nothing but it matches the data and all the data structure, like so if I have like 10 points and it has 10 points like this, so it matches this point, like this point with all the 10, like this point with all the 10. So you get like kind of square rooting, like 10 by 10, like that. So you get 100 values. So now we have 121 because like it has like 11 by 11. 11 by 11 is 121 if I'm not wrong. So you can increase it however you want, and what we can do is like check the branch here. Okay, what I can do is, there is the problem with the evaluator is like it gives me a list of point, but I just want to create a branch, so I can like create a branch manually. Oh sorry, x plus 1, I gave minus. So you can see here, so 25 points, like it creates a branch. So that's what, like sometimes you can manually create the branch with partition list or like so it's up to your call. So now you see here you have a branch. So now let me try to create a polyline. No, I want a polyline like in this way, so I'm going to flip the branch. So first you need to give, like when you're flipping it, like why I didn't create like or you might ask, bro, why it is not like vertical, it always create horizontal. Because if you see here when I take the list item, so if you see, that's the point. So you can see the point here, okay, and when I click so when I press one point, it goes from top to bottom. So technically it creates the branch in this way. So that's the reason why it creates, like you can see here, the point positioning in the list itself is like in vertically. So if the point position in the list is horizontal, then you can change the partition, like you will get horizontal. But you can do like flip matrix here. So now you can change the matrix, but the problem is here, like it's not a problem. This one is simple, like because you have 24 by 24, like you have 24 branches, 24 items. So flipping in this case is much easier. But when it comes to like uneven branches, uneven numbers, here comes the challenging part. So that is kind of an intermediate level. So it's the same thing, but the operation difference. Okay, like now explode it. So you have the segment. What you can do is you can dispatch or cull pattern. Let's see. Let's try to see dispatch. So you can see here, like 0 is taken 1, like 0 1 0 1 like that. But I just want like 0 1 then 1 0. I want like different like intermediate, like something like this, not like how can I do? So if you see here, every branch like following true false pattern. But let me try one thing. True false. So this is for first one, and then we are going to create and I'm going to reverse it. So it is like true false false true. Either you can do this, or else what I can do is repeat data, let's say like list length, sorry, tree statistic. So just like 25 count, okay, and multiplication. So each branch will have two values. So sorry, list length. So the length of the list. So we get like 50 values, and we got the length here. So it will repeat the same true false false true false false true for like 50 times. Now I'm going to partition this list 2 times based on the output. Okay. Now I'll just simplify. Let me try. Okay, we got it. So what I did is, like you can see here, now the true false was applying for all the branches, so we get it. So but now what I did is I created like a true false for like I created like another branch which consists of one branch true false, second branch will false true, third branch, so which matches the data structure with the curves. So we need to sort this, and we, so technically the dispatch element, you can see here the dispatch element is using the dispatch pattern for 0 indices, it's using the 0 pattern. So in this case I am just changing the pattern for every branch. So here I just use true false false true. You can work with different kind of pattern, like true false or true false false or false true false. You can manually, like you can create like these kind of patterns, which makes it more interesting. For now this is what I need it. Now I just need to extrude it, and so I just need to extrude it, yeah. But the problem here is I just need to match the length of this point. How do I get that? So because we never gave length anyway, it was created by the number of segment to be created. We need 25 values, it divides the length by 24. So either what you can do is you take the list item over here, yeah. We got something like this. Now what I'm going to do is I'm going to create like a middle point, or else I'm going to list item and I'm going to flatten it as it's based on the branches, so the list will be much more unique. I'll just reverse it for now. I want it from bottom to top. Okay, as the flattening is happening, the reverse is like it's not happening. So I give the flatten here. You can see the reverse is working here. Now I just took these two lines and let me put the middle point here. Okay, and let me find the distance between 2 points. I can do that from the top and bottom, but I prefer to do it from bottom, not from the top. Sorry about it. Just 254. This is the height we needed. So like extrude and so it's nothing but unit Z. It's like a brick. So it only rotates, but it doesn't like how to say. So you can see here what is happening here. Oh, sorry. It finds the distance between these 2 points. So I need to deconstruct it. I need to find only the Z value of these 2 points. So it finds the distance. So that's why you have the error like this. Let me try subtraction. Okay, from top to bottom. Yeah. Sorry, my bad. So now, okay, but I don't want to be like joining here. What I can do is I can extend this curve over here to 50 and 50. Let me try this. Okay, not bad, right? Okay, now I need to extrude it. So as you see here, like each one has their own extruded direction over here. So how can I do that? But in this case we have a plus point, like you can see here the value it also has normal, which gives us the direction. So what I can do is I can use this amplitude. Normal is like the perpendicular vector, okay, so which helps us to extrude, and you can extrude. Wait a sec. Okay, no. What happened is like, okay, wait. The problem here is like, it asks like, how would I say, this is a list of vectors, and this is a branch of vector. So technically, if there is like 100 branch and this is like 100 list, so one list has 100 vectors. So this is not good. So what I can do is you can see here like 625, but if you see here it will be like 15,000. So my bad. So that's why you always like stop the solver, like lock the solver and do it. So if you do this kind of mistakes by any chance, you can sort it out. Like then recompute. I hope it works now. Why it takes time? Because like it created a big mess out before. So you just need to clear that, and like usually it doesn't create, like you can see here. Now 7,500, but why? It's 12. Okay. Okay. No, this is also a problem. So what I can do is I'll just flatten this and I'll just craft it and simplify. Let me try this. Yeah. So you are like 625. 625. Wait a sec. It has only 300 values. And why it has 625 values? Hi. It's 625. Yeah, okay. I just dispatched the pattern, and which I didn't do it here. So you can see here, like I just dispatched this pattern. So I need to follow, like you can see, like it has like 300 over here. If you see here. So what is happening here is like, okay, it's not going to work. Like not work, but I'll just use this. Like I need to rework on the branch and dispatch again. I'm just lazy to do it. What I can do is I'll take a middle point, curve closest point, something like that. Let me try this. Okay, let me try the area and beat up closest point. So you get a vector here, if you see here, and let me use the beat up. So you get the vector for everything, which is a really good amplitude, and extrude. I'll just give the extrude here. I think now it works. Yeah. Let me give like 25. I don't know exactly. Maybe 100. Okay, this is cool. But I just don't want to be like one-sided. If you want, what I can do is like division by 2. So it's 50. First, I can move it with this amplitude, and then let me put like -6 so it goes back side, and then I'll just extrude this. So in this case, you can see it's in the center line. It's aligned to the curvature or center, like the surface center, which is cool. But it's up to your call. Like it's your requirement. These things. This is just a basic thing. So now you can extend if you want like 55. So the thing is, like if you have a brick size and if you want to do to a real scale size, you need to consider the gapping, consider the curvature, like these things before you work on the Grasshopper script. So in this case it works fine for me. I don't know. Let me know your comments, and you can also let me try to match that surface I created. It's here. So this is the base surface. So let's say like I jitter like a little bit. You can see it changes. If you want, like you can also create a curvature. Like you can manually create. I just want to like. So ortho is turned on. I just want to turn off the ortho. Okay, let me create some curve like this. Set one curve. Loft it. Okay, I need to flip this because you can see it starts in different way, like flip curve. Where it is. That's cool, right? But I just want to like move it inside, and now what I can do is I can just create it. Yeah, what do you say? So in this case, like you need to alter the because the problem here is like the curvature here, it like how do I say, it is outside the span of the top curve. Like loft is not like straight. So in this case you need to do more calculation to work on this mathematics. So you want like this not to be bigger. So here the separation can't be true or false. You need to work like it's the next step. So this like that's what Grasshopper evolves. Like whatever you do is like whatever I do right now is like basic. And once you have the understanding of basic, then I'll do the intermediate level, like where the same concept, but here if you see here the brick size is like I want, let me say like I want the same brick size all over. So what I can do is like I can take the curve separately and work on it, or like there's like multiple options to do it. That's make it like same tools, but the end result, the request of the result makes it like which level it belongs. Okay, that's all for the video. Let me see you in another video. And if you don't subscribe, please do press the subscribe button and see you in the next video. Bye bye.